Hello everyone. A very good evening to all of you. So let's wait at least for 5 minutes so that everyone can able to join the session. More Leslie, the previous year assignments, I have gone through the some questions uh, in my class. That are the previous year questions. Some questions are the similar type because the previous year question and this year questions in your assignment problem are same. So some question may not be taken, but because that question is the current assignment. But that type of question I have tried to solve here so that you can solve the questions for the current assignment. So you can go through that in my folder. So just I will share here. Now it's audible. So you can go through this docs. So my name is Pooja Verma. So in uh, my list, you can just check, go to the Google Docs, the Google Drive link. From there, you will get all the questions PDF. Is it now audible? And for this, can you increase your volume little bit because I have increases it. And to others, is it audible? Now it's fine, Ninad. Okay. Okay, let's start the session. Hello everyone, a very good evening. My name is Pooja Verma. I am a married research scholar from IIT Kharagpur, and instructor for this course is Dr. M.K. Bhuvan, Department of Electronics and Electrical Engineering, IIT Guwahati. This is a week 12 live and interactive session on computer vision and image processing, fundamentals and applications. So, I hope all of you have gone through this week video lecture. This is our last week, week 12. So, so any one of you can confirm it whether I'm audible and visible clearly. Okay. This is our course layout. Now this is our last week, week 12. So in this we will see some questions related to applications of the computer vision. So for this week is the that is course content that is covered. That is gesture recognition, object tracking, background modeling and motion estimation, and some programming examples, right? For asking and interacting, you can use the chat box, otherwise you can unmute yourself and ask your question. So let's move some questions related to this week. So this is our first question. The question is, which of the following equations represent the fundamental brightness constancy constraints used in optical flow estimation, where Ix, Iy, and It are image derivatives and uv are the flow velocities. Which option can be a correct one? Please try to make it interactive, at least answer or guess something. Which option can be a correct one? Okay, yeah, writing now. So here we will see in-depth numerical. Yeah. So yeah, so the fundamental assumption on the optical flow is the brightness constancy, meaning the pixel intensity of an object remains the same as it moves from one frame to the next frame, right? Just a minute. So let's see, it is our one frame that is a x, y, t at a time, and it is moving to the next frame I x plus bx plus comma, so y plus dy and t plus dt, right? So using so we will solve it using the first order Taylor series expansion on this equation, this one. So this is our like first frame, it is our next frame, it is based on that. So using Taylor series equation, series expansion on this equation, we can approximate the change. So as we know that I x y t is equal to, if we expand using the Taylor series expansion, so it will be the I x y t in this the right side. If you see that left side will be same, right? And plus del I by del x dx plus del I by del y dy plus del I by del t dt. This is a using Taylor series for expansion. We use this equation, we expand this equation. So as we see that this will be the cancel out, so that means del I by del x dx plus del I by del y dy plus del I by del t dt is equal to 0 here, right? So now what we need to do, we will divide this equation by dt. Okay, and now we need to define the optical flow velocities, right? That is given velocities, that is that means u is equal to, here we are assuming that dx by dt and v is equal to dy by dt. So this is the assume. Okay, so now we will divide this equation by dt. Okay, so here it is written. So here what will be, we will get del I by del x dx by dt, because we are dividing the whole equation, and here we will get del I by del y dy by dt plus del I by del t, and here dt by dt is equal to 0. So then this dt will be the cancelled out, and here we have assumed that dx by dt is u. So del I by del x into u, del I by del y into v, because dy by dt is v, and plus del I by del t. Now we will use the notation for just a minute. So after this, using the notation Ix, Iy and It for the image derivative. So these are the image derivatives using notations Ix, Iy and It. So I'm just removing it from here. I hope all of you have noted down. So here, from here, using the notation of It for image derivatives. Okay, image derivatives. So here del I by del x is equal to Ix, del I by del y is equal to Iy, and del I by del t is equal to It. So in this equation, if we put, what we will get, Ix into u plus Iy into v plus It is equal to 0, right? So this is our final derivation for this. So if you just read it, so you will get, so option D is the correct answer. Okay, so yeah, option D is the correct answer. Is it fine to all of you? Have you understand? Any doubt? Yes. Okay, so can we move to our next question if you don't have any doubt? So if you have any doubt, so you can ask there or unmute yourself and ask. Then Okay, I hope is it clear to all of you. Now moving to our next question. Now our next question is an image of size 800 into 600. 800 is width and 800, 600 is height. Okay, to resize it such that the maximum dimension is exactly the 200 pixels, which while strictly preserving the original aspect ratio. So what will be the new dimension of the image? So any one of you can answer for this question. What will be the new dimension or how it can be solved? So here image dimension is given, and also it is given that to resize it we need to use the maximum dimension, and that should be maximum dimension should be exactly 200 pixels. Okay, and we need to maintain the original aspect ratio as well, that is height into width. So what will be the new dimension? Okay, yes, yeah, correct now. No, not a constant. So aspect ratio, then you have to multiply for the new scale factor. Okay, so we will solve it here. So to resize 800 into 600 image while preserving the aspect ratio, so the maximum dimension is exactly 200 pixels. So the maximum dimension here, what is? It is our 800. So maximum dimension is width here, that is 800 pixels, right? So first we need to calculate the scale factor first, then we have to calculate the new dimension. The scale factor will be equal to, so new maximum dimension by old maximum dimension. So new maximum dimension, what would be we need to pick? Exactly 200 pixels. So 200 and old our 800. So here we will get 1 by 4, and further you divide it. So 0.25 is our scale factor. Now we need to apply this scale factor in both the dimensions to calculate. So mu width is equal to, the older width is 800 and our scale factor is 0.25. If you just multiply it, you will get again 200 pixels here, and new height. So old height, that is a 600 into scale factor. Okay. So if you just multiply it, you will get 150 pixels. So now new dimensions are so 200 into 150. Okay, 200 into 150. So here the maximum dimension is exactly 200 there, that is asked in the question, and 150 is the, and it will maintain the, no, it's given as Anand in the question. If you see that the maximum 200 pixel is not mentioned as a width. It is asked in the question, if you see in the read of the question, to resize it with the maximum dimension is exactly 200 pixel. It's not, so it can be a height or width. So in the height or width, they need maximum dimension is 200 pixels. So here it is mentioned, not as a width or height. So they have asked in height or width. It should be one of the dimensions should be 200 pixels. Okay. 200 by 600, why we are calculating. So for the maximum dimension, we need to calculate the scale factor because we are here, don't need to calculate by 200 by 600. So here, just read the question. An image that is a given 800 into 600 width and height. This dimension fixed image size is given. Now they are asking that to resize it, we need to resize it. So for resizing it, one of the dimension that should be a maximum exactly 200 pixels. It can be a height or it can be a width. So for to keep it maximum dimension 200 pixel in the new dimension. So that's why we are choosing here 800 because 800 into 600, this is 800 is the maximum. So for a scale factor, that's why we are choosing the 800 as a maximum dimension because it has a maximum pixel. So for that, we are calculating the scale factor, and that scale factor will be multiplied by in these two, so that we will get the new dimension. Is it fine now? Okay. So any doubt or any, is it clear now? Why we are doing, why we are not taking 200 by 600? Okay. So can we move to our next question? Is it clear? Okay, Anand, is it fine to you? Okay. So can we move to our next question? Okay, I hope all of you have understand. Now moving to our next question. Okay, so our next question is here. It is given that probability of C1 is 0.7 and probability of C2 is 0.3. And also given probability of x given C1 is 0.2 and probability of x given C2 is 0.6. Now we need to find out the probability of C2 given x. So this is the probability based on the Bayes theorem. So any one of you can tell how we can solve. So probability of C2 given, yes, that is based on the Bayes theorem. So probability of P given, probability of C2 given X is called a post-ready probability. So it is based on the Bayes theorem. So just apply the Bayes theorem. So Bayes theorem is probability of C2 given X is equal to so probability of C2 given X is equal to probability of X given C2, probability of C2 by probability of X. Here I am taking and probability of what is our probability of X? This is the total probability or given. So probability of X given C1, probability of C1 plus probability of X given C2, probability of C2. So first we will calculate it. The probability of X given C2 is 0.2 and probability of C2 is C1, sorry, is 0.7. plus 0.6. Here probability of x given C2 is 0.6 and probability of C2 is 0.3. So if you just multiply here 0.14 it is, and it is 0.18, and the answer will be overall if you add 0.32. Now we need to put in the probability of, yes, that's correct. Now probability of C2 given x is equal to probability of x given C2 is 0.6 and probability of C2 is 0.3 and probability of x that we have got 0.32. So now 0.18 by 0.32. So if you further just calculate it to 9 by 16 and overall the ratio you will get 0.56 to 5. So 0.56. So it is 0.09 by 2. So 0.16. So from here you will get 9 by 16. Okay, so 0.56. So answer B is the correct answer for this question. So is it fine to all of you? Yeah, most of you have given the answer. Okay, so is it fine to all of you? So I hope all of you know that. Okay, so moving to our next question now. So next question is the theoretical base. So question is, which of the following is a key limitation of the standard k-means clustering algorithm compared to a Gaussian mixed model? So option A is it requires an infinite amount of memory to compute. Option B is it provides a non-parametric estimation of the probability density function. Option C is it assumes that all clusters are spherical and have a equal variance. Option D is it is unable to assign a definitive hard label to data point. Which option can be a correct one? At least guess for this question, then we will discuss in detail or give you a detailed explanation for this one. At least try to answer for this question. Okay, Priya is saying B, Anand is saying C. Okay. So here the question is asking which of the following is a key limitation of the standard k-means clustering algorithm compared to the GMM model. Okay, anyone else who would like to answer for this question? Okay, okay, so let's see the detailed explanation is here. So we will go to the options, what options that is means, each options what it is saying. The option E is it requires an infinite amount of memory to compute. So K means is actually known for being computationally efficient and it's scaling well to large data set. So it does not require infinite memory. It requires it memory uses is generally linear with respect to the number of data points. Okay, so it can't be a correct answer. It requires infinite. So based on the data set or number of data points, it requires that much amount of memory only. So our option B is it provides a non-parametric estimation of the probability density function. So in the k-means clustering is not a density estimation tool, it is a distance-based clustering algorithm. So we are calculating the distance between each cluster, right? And based on that, we are just making the different clusters. And the GMM is a parametric generative model, so that estimates the probability density of the data as a sum of the Gaussian distribution. Okay, so K-means clustering is a not a density estimation tool. Okay, so this is also not a correct answer. Now, option it is a not a limitation again. So option C is it assumes that all clusters are spherical and have equal variance. So in the standard K-means clustering algorithm that uses the Euclidean distance to assign points to the nearest centroid. So that mathematical approach inherently assumes that each cluster is circular and spherical in shape, and that all the clusters have roughly the same variance. You can say that. And in contrast, the GMM is far more flexible. It incorporates the covariance matrix for each cluster, and that will allow it to identify elongated, elliptical, or rotated clusters that have varying size and density. So, yes, in the K-means clustering, it is a limitation that each cluster assumes that it is a spherical or circular in shape. So this is a limitation of the K-means clustering. So option C is the correct answer for this question. Let's see quickly see the option D as well. So it is unable to assign a definitive hard label to data points. So this is the opposite of the truth. So K-means only assigns the hard label. That meaning every point belongs to exactly one cluster. And in the GMM, that provides soft assignments, that is giving each point probability of belonging to the various clusters. So correct answer is C. It assumes that all clusters are spherical and have equal variance. So yeah, option C is the correct answer for this question. Is it fine to all of you? Yeah, option C is the correct answer. So I hope all of you have understand. So now moving to our next question. So yeah, our next question is, in computer vision, the motion of the pixel between the consecutive frames is often estimated using the brightness constancy constraint, as we have in our seen our first question. So given the following image gradients and the temporal derivative at a specific pixel, so a special gradient in x direction, that is Ix, is given as a 3. Spatial gradient in y direction, that is Iy, is given as a 2. And temporal derivatives it is given as a -4. So which equation correctly represents the relationship between the horizontal velocity u and vertical velocity? So which equation is represent? Yeah, which option can be a correct one? Okay, yeah. So yeah, already we have seen the theoretical part in our equation one. We have derived the whole equation. So the okay, so as as we know that the fundamental equation for the optical flow, equation for the optical flow is Ix into U Iy into V plus I t is equal to 0, right? And Ix is del I by del x, as we know that spatial gradient in the x direction, del I by del y is the spatial gradient in y direction. It is given here, and it is a temporal derivative. So here these values are given. So Ix is given as a 3. So 3u, and Iy is given as a 2. So 2v, and it is given -4, and -4 is equal to 0. Right? So if you further just derive it, so 3u plus 2v is equal to 4. So this is our equation, or you can say that this equation that represents the relationship between the horizontal, this is the horizontal velocity, and vertical velocity v. So 3u plus 2v is equal to 4. So yeah, option A is the correct answer for this question. So this one is a simple one. So I hope all of you have understand and know that. So can we move to our next question? Okay. So moving to our next question. So now our next question is based on that concept itself again. So in computer vision, the motion of the pixel between frames is governed by the brightness constancy assumption. So given the following spatial and temporal image gradients, so horizontal gradient Ix is given as a -2, vertical gradient Iy is given as 1, and temporal gradient It is given as 3. So now the question is, which of the following velocity pair, that is a uv, satisfies the optical flow constraint? Now which pair that satisfy the optical flow constraint? So here we need to choose that u and v, so that satisfy the equation of the fundamental of the optical flow. So which option can be a correct one, or anyone of you tell how we can solve this question to find out the velocity pair? Okay, -2u plus v is equal to -3. Okay, yeah, that is it correct. So let's solve this question. So again, as we know that the fundamental equation for the optical flow, that is Ix into u plus Iy into v plus It is equal to 0. Okay, so Ix is given here -2, u, Iy is given as a 1, so 1 into v, and It is given as a 3. So 3 is equal to 0. So now if you just write it, so -2u plus v is equal to -3. Or we can write it like this, 2u minus v is equal to 3, right? We can write. Now we need to choose the velocity pair that satisfies this equation. That means 2u minus v, we need to choose u and v values such that that should be equal to 3. So here we will go through the option, test by options. So this is the best strategy for this one, test by options. So our option A is 1 and -1. So that means u is equal to 1. So 2 into 1 and v is equal to -1. So minus of -1. So 2 plus 1, that is equal to 3. So 3 is equal to 3. So this is matching, but just you can check with the other options that can be a multiple select questions as well. In the exam they can ask. So don't just stuck on this. If you answer, you find your answer. So just go to the option B as well. So -1 and 1. So 2 into -1 and V is 1. So 1. So here -2 -1, that is equal to -3. And that is not equal to 3. So option B is not a correct answer. Now we will see to the option C. So I'm just writing for C here. 1 and 1. So 2 into 1 minus 1. So that is equal to 2. Sorry, 1. It is equal to 1. So that is also not the correct answer. And D is -1 and -1. So here you will get -2 into -1 and minus of -1. So yeah, 2 plus 1, right? So here minus, sorry, in this equation we need to put, so here minus 2 will be there. So here you will get minus 1, and that is also not equal to 3. So this is also not a correct option. So here it is option A only, but many of the questions we will get the multiple select options as well. Okay, so I will suggest you when you see the question, we'll go to if you are getting the option A, but you should try for the another option as well. It is a very if you're fast enough, so you can do it, right? So is it fine to all of you? Can we move to our next question? Okay, so moving to our next question now. Now our next question is in dynamic time wrapping path, that is W is equal to W1, W2, Wk, and Wk is equal to Ij must satisfy specific condition to be considered valid. Given two sequences of length n and m, which of the following represents a mathematically valid DTW alignment path? So here we need to choose the valid alignment path from these options. Which options can be a correct one? So how we can choose the valid DTW alignment path? Which one is the best?
Third option is correct because in all the other three, there is a jump. If we see continuity is not there.
Okay, that means it is violated the continuity rule.
Yes.
Okay, so as we know that a valid dynamic time wrapping path must satisfy the three fundamental conditions, right? First one is a boundary conditions. Second one is a monotonicity. That means the indices never decreases. It should be increased by one. And next one is a continuity. So each step can only move only one unit at a time in either both directions. So for the valid transitions. So first one is boundary conditions. That means path must start at the first indices and both the sequences are 1 1. And at the end it should be the last indices. So for a valid DTW alignment path that must be satisfy three fundamental conditions. That is first one is a boundary condition. Second one is a monotonicity. And third one is a continuity. So continuity means each step can be moved only one. And monotonicity, that means it never decrease, it should be increase. And boundary condition means that it should be start at the first indices and end at the last indices only. So we will go through the options and check which one is a valid alignment path. So if you see that equation 1 in the both x and y, we will see 1 and then 2, 3 and 4. So in the x direction it is fine. For the y, 1, 2, here it is a 4. So it has jumped 1. So it should be plus 1. So it is not a valid alignment path. Now, so it violates the continuity. Now we will see that for the second option, so 1, 2, 3 and 4, it is fine. Now it's 1, then 3. So it should be plus 1. So it is also violates the continuity condition. Now we will see for the option C. So 1, 2, again 2, it should be same. It should be increase but should not be decrease. 3 and 4. So it is correct. 1, 2, 3 and 3, 4. So it is a correct because it is not violating any rules. All rules follows this one. Now option C is 1, 3. So again it violates the continuity equation condition, and here also 4, 5. So here it is decreasing. So it should not be decreased. So yeah, option C is the correct answer for this question. Is it fine to all of you or any doubt? Okay, so I hope no doubts are there. So moving to our next question now. So our next question is related to theoretical again. So for a two sequence A, that is a length n, and B is the length m, the boundary condition constraint in DTW that dictates that the optimal wrapping path must start and end at the grid at which grid coordinates. So here we are assuming that one ways indexing. So option A is start at 1 m and end at n 1. Option B is start at 1 1 and end at n m. Or option C is start at 0 0 and end at m n. So option D is the path can start and end anywhere as long as it is continuous. Which option can be a correct one? Option B. Okay. Okay. So if you give an answer, so let's see the detailed explanation for this one. So the boundary condition in the dynamic time wrapping ensures that the alignment account for the entirety of the both sequence. So under one based indexing or for a sequence of length n and for v it's m, the optical wrapping path must be. So we will see through the options as well. So option A is start at n1 m and end at n1. Reversing the indices, that is a 1 m and n1, would imply alignment to start at one sequence and end at of another, which contradicts the goal of temporal alignment. So this is not a correct answer. And option B is it starts at 1 1 and end at n am. So in the boundary condition, as we have seen, that is one of the fundamental constraints of the DTW. It the elements of the both sequence start point is 1 1 and end point is the last one, that is nm. It can be any value. So this constraint ensure that no data at the beginning or end of the either sequence is omitted from the alignment process. So while the other constraints like monotonicity, the path must not be go backward in the time, and continuity, the path must not skip any elements that governs the same shape of the path, and the boundary condition defines its fixed endpoints within the cost matrix grid. So yeah, this is the only the correct answer for this question. Now the next question starts at 0 0, so and at mn. So 0 0 to mn uses the zero waste induction or swept dimensions, but not a standard one waste convection. So this is a not a correct one because it starts at 0 0. Here in the question they have a one waste indexing. Option D is that the path can start at and end anywhere as long as so allowing the path to start and end anywhere that describes such sequences DTW or open-end DTW, which are a specific variation, not a standard DTW. So option B is the correct answer for this question. So this is it starts at 1 1 and end at NM is the correct answer for this question. So is it fine to all of you? I hope. This is the basic question you are getting, you must be getting. So is it fine? Can we move to our next question? So yeah, most of you have given the correct answer for this question. Okay, so I hope all of you have understand. So now moving to our next question. The next question is also theoretically. So question is when attempting to isolate moving objects in a video feed, that feature is a dynamic, non-static background such as a rustling tree leaves or rippling water. Which background modeling technique is most appropriate? Option A is simple frame differencing. Option B is Gaussian-Wilson models. Option C is global image thresholding, or option D is a static mean filtering. Which option can be a correct one? When attempting to isolate moving objects in a video feed that features a dynamic non-static background, which background modeling technique is most appropriate? Okay, so let's see the detailed explanation here. So we will go through the options. So option A is simple frame differencing. So this method is highly sensitive to noise and cannot differentiate between the small backgrounds and movements like leaves and actual foreground objects. So that results in many false positive in dynamic scene. So this is not a correct option because that will produce the many false positive results in that case. And option B is Gaussian mixer models. So GMM, that is most appropriate background modeling technique for the dynamic non-static background. For example, for the rustling tree leaves and rippling waters or fountains. So there are some points for the Gaussian mixer model. First one is a multi-model background handling. So the standard technique that like simple frame referencing or static mean filtering assumes each pixel has a single or constant value in the background, and GMM model each pixel using the multiple Gaussian distribution mode. And adaptability to motion, and in the dynamic scene, a single pixel might represent water at one moment and glint to the next, or leaf, then sky. So GMM can maintain multiple normal states for a single pixel that allow is to ignore repetitive motions like rustling leaf, rippling water, and still identify the unique moving foreground object. And the another characteristics of the GMM is robustness to complexity. So, so this highlights the GMM is specifically designed to handle multimodal background scenarios where simpler methods fail due to noise and environmental fluctuations. So yeah, Gaussian Mixon model, that is a correct answer for this question. And our next two options are global image thresholding. So this is a static operation that is applied to a single image to separate pixel based on the intensity. It is not related to the background modeling and in the dynamic static background. So static mean filtering is also assume single static mean value for the background, and because of it cannot account for the multiple states. So like oscillating motion of the branch, it typically creates a blurred background model and fail to isolate foreground object accurately in a dynamic environment. So most appropriate technique for isolating moving object in a video feed with the dynamic non-static background is the Gaussian mixer model in the given four options. That is the best strategy. So yeah, correct option is the option B, Gaussian mixer model. So is it fine to all of you? Yeah, option B is the correct answer for this question. Okay, Okay, so I hope all of you are getting no doubts yet. Okay, so moving to our next question. The next question is based on the in a particle filter used for the visual tracking, what does each individual particles mathematically represent? Option A is a single moving pixel in a background. Option B is the hypothesis or a specific state vector that is a position velocity of the target. Option C, a distinct color bin in the target's image histogram, or option D is a static feature point extracted using the SIP algorithm. So, which option can be a correct one for this question? Anyone else would like to answer for this question? At least guess, make a guess. Okay, okay, so let's see the explanation here. So we will go through the options. So first option is a single moving pixel. So in a particle that represents the state of the entire object or a specific hypothesis of not just a single pixel. Okay, so that particle that is the state of the entire object we need to here taken into account for this question for the particle filter using the visual tracking. Option A is not a for only for single moving pixel. It cannot be. Option B is the hypothesis or a specific state vector, for example, position, velocity, scale of the target. So in a particle filter that is also known as a sequential Monte Carlo, each particle that represents a point mass or a discrete sample from a probability distribution of the target's state. So in the each particle of the state vector St that encapsulate the parameter of the object being tracked and such that its x and y coordinate, velocity, and sometimes its scale or orientation. So that collectively the state set of the particles represent the conditional probability density. So that is a P given St by I0 I2 I0 to T of the target's state given the observed image. So option B is the correct hypothesis that is specific state vector of the target. Now option C is the distinct color bin. So the color histogram are often used for features to calculate the weights of a particle, and the particle itself is the state vector, not a bin. So option D is the static feature point. Then the set point are features that is used for detection or matching in a particle filtering that these might be used to update weights but not a particle define the hypothesis, location and motion of the target as a whole. So yeah, option B is the correct answer for this question. In a particle filter that is used for visual tracking, a hypothesis or a specific state vector that is the position, velocity or scale of the target individual particle mathematically it is represented by this one, a hypothesis or a specific state vector. So option B is the correct answer for this question. Anina, it is option B is the correct answer. Is it fine to all of you? Can we move to our next question? Okay, so moving to our next question. Yeah, next question is given the sequence that is x is equal to 1349 and y is equal to 124910 with the distance metric that is dij is equal to xi minus yj mod of what is the value of the accumulated cost matrix at D is equal to 2, the cell corresponding x2 is equal to 3 and y2 is equal to 2. What will be the value of the accumulated cost matrix? Here two sequences given. We need to calculate the distance, that is using this one, and at D2, that means here x2 is equal to 2 and x3, the cell corresponding x3 is equal to 2 and y2 is equal to 2. We need to calculate. It should be 2. X2 is equal to 2 and y2 is equal to 2. No, it is written at the value, so it is correct. So here two sequences are given. How we can calculate the cost matrix? Anyone? Here the distance is also given. So this question is related to again DTW itself, dynamic time wrapping. Anyone would like to answer for this question? We will solve it here. DT. Okay, so let's solve it. So first we need to compute the cost matrix. Cost matrix. How we can calculate the cost matrix using this distance metric formula. So Dij it is given as a is equal to mod of xi minus yj. Right? Here two sequences are given, so we need to calculate the distance between the each sequence. So we can make a one matrix, right? So let's see for the x we are writing 1 3 4 9 here, and for the y x given y we can say that for 1 2 4 9 and 10. So if you just make a this is the x value, this is the y value, so it is a mod, so that all values will be positive, right? So 1 minus 1 will be 0, 1 minus 2 is minus 1, and minus 1 mod of minus 1, so 1 will be 1 there, 1 minus 4 is 3, 1 minus 9 is 8, 1 minus 10 is 9, right? Now similarly for the 3, we need to calculate for the each value. So 3 minus 1 is 2, 3 minus 2 is 1, 3 minus 4 is 1, 3 minus 9 is 6, and 3 minus 10 is 7, right? Similarly for 4, so 4 minus 1 is 3, 4 minus 2 is 2, 4 minus 4 is 0, and 4 minus 9 is 5, 4 minus 10 is 6. Similarly for 9, so 8, 7, 5, 0, and 1, right? So this is our cost matrix, distance between each values in the given sequence. So for the DTW filling matrix, or to calculate the cost at this D22, so the formula for this one is Dij, this is a small d, is equal to Di of j plus minimum of Di minus 1 j at this position, comma Di j minus 1, comma Di minus 1 j minus 1 position. At the minimum from the three locations we need to choose. That means left, top, and the diagonal, and the corresponding Dij, that is a distance between them. So for example, we need to calculate here the cost accumulated for the D22. So Dij D22, that means at this position here we need to calculate, right? For the D22, so for D22 we need to calculate the distance at D22 plus minimum of the positions D I minus 1 to 2 minus 1 is 1 and 2, right? Comma D 2 comma 1 and here D 1 1, right? So like this you have to calculate. So D22 we know that that is a 1, and for the other these three values we need to calculate, right? So this is related to 1 2 means this one, 1 2 this one. We need to calculate 2 1 is for this one and 1 1 is this one. So for this, first we need to calculate for D 1 2, right? So D 1 2 means D 1 2 plus minimum of the left upper and that diagonal matrix. So D here 1 first, so 0 I minus 1, so 0 to D here I is 1, so 1 1 and D 1 2, so 0 1, right? J minus 1, so J is 2, so 2 minus 1, yeah, correct. I minus 1, so 1 minus 1 will be 0, yeah. So D12, what is our distance that is given? 1 at 1 2, it is 1 plus we need to choose minimum of D02. So again we need to calculate. So we have to choose minimum. So the diagonal, if you see that, so it is a left, the top it is nothing. So 0 you have to choose and diagonal is nothing. So minimum will be the 0 itself because for the it is the first row. So for the first row where we can calculate the left, top and diagonal values of the DTW. So it would be the 0 0 and the value is the diagonal is I think 1. So for 1 2 you will get 1 plus 0. So 1 you will get for D12. D21 similarly you have to calculate for the D21. So it is 2 and if you see that upper left nothing is there and diagonal is there, so it will again 0 because the top left upper one is a 0. So we have to choose the minimum. So here 2 again. So D21 is the 2. Now similarly we have to calculate for D1 to D11. So D11 is 0. The value itself is 0. So D11. I'm just writing here for the D11. So the value itself it is 0 and left right corner all the values is 0. So D11 will be the 0 itself. It will give the 0. So like that we have to calculate it. Now we need to put in this matrix. So I'm just removing it here. So D22 is 1 plus minimum of 0, 1 and 2. So 1 plus minimum is 0. So overall the value you will get D22 or is 2. Sorry, 1. So if you see that option A is the correct answer for this question. Is it fine? Yeah, Priya, it's correct. 1 plus minimum of 1, 2 and 0, or you can write it in 0, 1, 2. So is it fine to all of you? Have you understand this question? How we are calculating the accumulated cost matrix for the given location D22? Is it fine?
Ma'am, I have a
Yes,
doubt.
yes.
When you computed the minimum, are we just looking at the adjacent elements and computing, or are we again using a recursive formula for that?
We will choose only the in the formula. You can see that uh, it is written at this location. We need to choose I minus one j. So when you are putting the values, so you can calculate these values as well. So 1 2 2 1 I minus 1 j. So that is basically left, top, and diagonal element we are seeing here.
Yeah, just
So
the elements, right? Okay.
yeah, this in this.
Okay. Thank you.
Is it fine? So if all of you have understand, can we move to our next question? Okay, I hope all of you have understand. So now moving to our next question. So here the solution is also given. Now our next question is for the sequence x that is equal to, again the same question is there. Sequences means which of the following represents the optimal alignment path that minimize the total global distance. So here they are asking about the which optimal alignment path that minimizes the total global distance. So can you answer for this question? Each one is the optimal path. So option D is eliminated because it violates the continuity rule, right? So in the next three options, we choose one that is a has optimal alignment path and that also minimizes the total global distance. So total global distance means you have to calculate the distance as Dij. We have seen that is xi minus yj, which have a minimum global distance. So all the three equations are following all the rules. So all the three are the optimal alignment path, but we have to choose that minimizes the total global distance here. So how we can find it? So can you calculate and let me know what will be the total distance in each cases? And whatever whichever have a minimum distance, that is the our answer that follows the optimal alignment path and also minimizes the total global distance. Okay, so this is answering for option B. Okay, okay, so let's see here. So for each we have to calculate the difference. So to determine the optimal path, we have to calculate the total distances, the sum of the absolute differences, that is aligned element for each options. So our option A is 1 1, 2 2, 3 3, 4 4, and 4 5. So x1 minus y1, that is 0, x2 minus y2, that is 3 minus 2 is 1, 0. Like this we have to calculate. So x x3 minus y3 is 4 minus 4 is 0 again, and x4 minus y4 is, it's wrong here calculated, so we will calculate it here. So that means first one is b 1 1, we need to calculate. So x1 minus y1, so it is 1 minus 1, that is 0. Similarly we have to calculate for 2 2, b2 2, so x2 minus y2, so again it will give a 0, and here for it is giving the 0. 0, 0, 0, and here 4 minus 1 is 1. So total global distance for option A is 0 plus 0 plus 0 plus 0 plus 1, that is equal to 1. Similarly, we need to calculate for option B. I'm just checking here option B. So 1 minus 1 is 0, 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 4 is 0, and 4 minus 5 is 1. So here the total global distance for all is 3. For option C, it is a 1 minus 1 is 0, 1 minus 2 is 1, 2 minus 3 is 1, it is 1 plus 1. So it is a 4. And it violates the continuity rule, so don't need to calculate it. So if you see that the minimum distance, that global distance is for option A. So option A is the correct answer for this question. It has a, these two has a maximum global. That means it has a greater than option A. So that's why we will choose the option A is the correct answer for this question. Is it fine? How we are calculating it? We have to choose the optimal alignment part that has a minimum total global distance. Yes, you can find the previous matrix as well, but it is a alignment path, right, between these values. So directly you can calculate here to these one. So here the path is given. So from the path we directly calculate it.
For 2, 2, it should be 1, I think.
For 2, 2, which one? 2 minus 2, it should be
First,
0,
first
right?
option.
So 2 minus 2, it will be 0, right? Because we are calculating for D 2, 2. So
Okay,
2
just
minus 2.
okay. Okay.
Okay, so is it fine to all of you? Can we move to our next question quickly? Okay, so moving to our next question now. So next question is, in a standard convolution layer without padding, it is given in an input of size 128 into 128 is processed using the 7 cross 7 kernel with a stride of 2. How many total sliding window positions that points in the output feature map are generated by this operation? How many sliding window positions that is generated by this operation? Anyone? How we can solve this question? Okay, let's solve it here. So as we know that the output feature map is determined by output feature map is mined by, that is a I minus k plus 2p by s plus 1, right? So this is a stride. As we know that this is a padding, this is a input, sorry, kernel size, this is one is a input size. Okay, so all these values are given. Input image size is 128 cross 128. So 128. So 128. Kernel size is 7 plus without padding. So there, that means there is a no padding. So that would be 0. 2 into 0 and a stride that is given of 2. Right. So if you just calculate it, you will get 121 by 2 plus 1. So if you just divide it, you will get 60.5 plus 1. The floor value will be the 60. So 60 plus 1 is equal to 61. So the output feature map is map is 61 cross 61 here. So now to find out the total sliding window positions or that is generated by this operation is by multiplying these two values, whatever we have got in the output feature map. So you can say that total operations I'm writing here is equal to 61 into 61. If you multiply these two values, you will get 3721. Okay, so this is the total operations that is generated in sliding window positions. So here it is also given points in the output feature map. So that's why we are calculating from the output feature map itself. So if you see that option A is the correct answer for this question. So is it fine to all of you? So is it fine? Have you understand this question? Okay. So 60.5, it is a floor value. We are taking 60 as a because we are always taking the less value. It is a middle. So we are taking the floor value that is a 60. So 60 plus 1 that is a 61. Okay. So now moving to our next question. So our next question is while dynamic time wrapping is highly robust for aligning temporal sequences without varying speed, so it faces significant challenges in specific tracking environments. In which of the following scenarios is a standard DTW based tracker most likely to fail? So option A is the object follows a strictly linear motion trajectory. Option B is the object speed varies significantly throughout the sequence. Option C is multiple similar objects cross path or move in a close proximity, that is, in the case of occlusion or identity switch. Or option D is the test sequence and the reference sequence have different total length. Which option can be a correct one? Anyone would like to answer for this question? Okay, no one will interested in giving answer. Okay, so let's see the detailed explanation here. So we will go through the options. So first one option is linear motion. That means the object follows the strictly linear motion trajectory. So this is a simple case for the almost any tracker, including DTW. It does not challenge the algorithm core mechanism. So this is not our correct option. Option B is significant speed variations. So this is actually DTW mean strength. So the algorithm wrapping capability allows it to line two sequences even if one is significantly faster or slower than the others. And option C is multiple similar objects cross path or move in a close proximity. In case of occlusion and identity switch, then the standard DW that is a primary sequence alignment algorithm rather than complete tracking framework. So while it is excellent at handling variation in speed, that is option B, and sequence of the different length, that is an option D, it lacks the inherently special awareness and identity management that is needed for the multiple object tracking. So ambiguity in the identity switch. So DTW matches the sequences based on the minimizing the global distance matrix. So when multiple similar objects move close together, their feature sequence becoming nearly indistinguishable. And without a sophisticated data association mechanism like a Kalman filter or Hungarian algorithm, a standard DTW based approach cannot differentiate between the objects, and that leads to a frequent identity swaps. And in case of occlusion, the DTW typically requires a continuous sequence to match. And if an object is occluded, the resulting noise in the data sequence can break the alignment. And as a standard DTW that expects every point in one sequence to be matched, at least one point in another. So this is the limitation of the DTW. So different total length. So DTW is designed to handle sequences different lengths by repeating, stretching, or skipping indices to find the optimal path through the cost matrix. So correct answer is the C. Multiple similar objects crosses a path or move in a close proximity. So this here DTW most likely to fail in the view of multiple similar objects that it cross the path. Okay. So option C is the correct answer for this question. So is it fine to all of you? Okay, so now moving to our next question. So our next question is, in the context of computer vision and robotics, trajectory tracking involves comparing a sensed movement path against the reference path. Why is dynamic time wrapping specifically preferred for this task? Option A, it acts as a primary edge detection filter for the image gradient. Option B, it aligns sequences that may vary in length or possess different temporal speeds. Option C, it is a frequency domain transformation used to remove Gaussian noise. Or option D, it computes the special derivatives to find intensity scenes in a single frame. Which option is the correct one? Okay, now this is option B. Okay, so let's see quickly because we need to cover some more questions as well. Okay, Anand. So let's see in the detailed explanation. So in the dynamic time wrapping, that is DTW, that is a powerful algorithm that is designed to find optimal alignment between the two dependent sequences. So in the trajectory tracking, it solves the alignment problem where two paths might follow the same spatial geometry but at a different speed. So first one is a temporal invariance. So robots or sensed objects rarely moves at a perfectly uniform speed. So in the DTW, that wraps the time axis to match similar points in a sense path to the reference path, even if one sequence is stretched or compressed relative to the other. And variable length as well. So unlike Euclidean distance, which requires sequence or equal length to compare the points between the identical times stamp, that is T1 to T2, T1 to T2 like. So DTW can compare sequence at different lengths by mapping one point in the reference to multiple points in the sense object or vice versa. Or next one is a pattern matching. It focuses on the shape of the movement rather than the synchronization of the clocks. So that makes it ideal to recognize gesture, gait, or movement signature where the pace of the execution varies. So the other option is right. Incorrect option A and D that describes a special gradient filter like a Sobel or Kenny that use image processing for edge detection, not for comparing the time series trajectory. And option C is that describes the frequency domain filter, that is a for Gaussian low-pass filter, that is used for signal smoothing, that is not performed for sequence alignment. So option B is the correct answer for this question. The alignment sequence may vary in the length and or pauses the temporal speed. So is it fine to all of you? Okay, so I hope it is. understandable to all of you. Moving to our next question. So yeah, our next question is, a network consists of two successive convolutional layers. Layer 1 has a 3 cross 3 kernel with stride 1. Layer 2 has a 3 cross 3 kernel with stride 1. Then what is the effective repetitive receptive field of the single neurons in the output of the layer 2 related to the original input? Actually, these are the questions related to our previous week 11, because the pen is not working. That's why I couldn't able to complete the last 5 questions. So this is the week 11 questions. So we will solve it here based on the previous week concept. That is also related to applications of the computer vision, right? So here they are asking what is the effective receptive fields of the single neuron in the output layer 2 relative to the original input. So we need to calculate the receptive layer. So the receptive field, that is of a neuron in a convolution neural network, that defines the region of the input that influence its activation. So for a sequence of convolution layer, the receptive field, that is receptive field here, it's denoted by RF, right? At any layer. So at layer, let's say L. So that is can be calculated by RFL is equal to RFL minus 1 plus KL minus 1, and that is into the summation of L minus 1 I to L minus 1 Si. That is a stride of the previous layers. Sum of, and here it is the kernel size at that layer, and RF to the previous layer it is. So first we need to calculate, here two layers are given, layer 1 and layer 2, right? So first we will calculate receptive fields for layer 1. So RF1, and so for this RF0 plus K1 minus 1, and it is a S for layer 1. So S I is equal to 1, so you can say that S1. So RF0, so this is the first layer, so RF0 will be the 1. So RF0 for the input layer, RF0 is 1. So for input layer, I'm just writing here RF0 is the previous layer, would be 1, always consider, plus K1 means kernel size. So it is given as 3 here. So 3 minus 1, and stride is 1, right? So 1 plus 2 is equal to 3. So now similarly we have to calculate for receptive field for layer 2. So RF2, that is equal to RF1 plus K2 minus 1 into, here S1 will be there because there are only one previous, because we are calculating the stride of the previous layer. So only one layer is there in this case, and if there are multiple layers are there, so that means the summation of all the layers. So RF1 we have calculated here 3 plus kernel size again 3 minus 1, and stride is 1. So 3 plus 3, 2, so 5. So the receptive field for the single neuron in the output layer is 5. We have calculated. So the receptive field of single neuron in the output layer, layer 2 is, that is 5 cross 5. So this is the final answer, 5 cross 5. Option B is the correct answer for this question. So is it fine to all of you? How we can calculating the receptive layer? I hope. Anyone doubt? Any doubt? So no doubts are there. So can we move to our next question? Okay, so moving to our next question. The next question is for a single neuron output y is equal to sigma z and target is t. The binary cross entropy loss is, that is L is equal to minus of t L natural log y plus 1 minus t ln n minus 1 minus y. What is the del L by del z? How we can calculate by del L by del z? So here L is given, right? We need to calculate del L by del z. So we cannot calculate directly. So the derivative for the loss with respect to input, that is z, can we decompose it? Del L by del z, can we decompose it by del L by del y and del y by del z? So we will get del L by del z, right? So here L is given as, so minus t ln y plus 1 minus t ln 1 minus y, right? So first, if we calculate del L by del y here, so what we will get if we differentiate this one? So minus ln y, if we take derivative, so we will get 1 by y, right? Similarly, for in this case also 1 minus y, and it is we are differentiating with respect to y. So again we will minus y, we will, so minus 1 we will get here. So if we just further, so here we will get minus of t into 1 minus y plus, because minus and minus will be cancelled out, so y into 1 minus t divided by y into 1 minus y. So now if we just expand this one, so minus t plus ty plus y minus yt by y minus 1 minus y. This will be cancelled out. So here we will get y minus t by y 1 minus y, right? And here it is also given y is equal to sigma z, and this one is the representation of the sigmoid function, right? So 1 by 1 plus, if the sigmoid function is represented by this one, here sigma z is the sigmoid function. Okay, so sigmoid function is represented by this equation, right? So now we can differentiate it by with respect to the z, del y by del z. So if you differentiate with respect to z, so what we will get? We can write it like this one also, 1 plus e to the power minus z to the power inverse, right? So now minus 1 first, that will be 1 plus e to the power minus z to the power minus 2, and d by just has stopped working. So d by dz 1 plus e to the power minus z will be there, right? So again, if we differentiate it, so what we will get? Minus 1, or you can say that like minus 2 square. So minus 1 plus e to the power minus z to the power minus 2. And here what we will get if we differentiate? So minus e to the power z, right? Because e to the power z into minus 1. So overall we will get e to the power minus z by 1 plus e to the power minus z whole square. We can write it like this one, right? So we have got del y by del z and del L by del y. So by multiplying these two values, we will get del L by del z, right? So now we can calculate it. No, we need to solve it more. So here we will get now. Just taking the one more slide to calculate it. Okay. So in the previous del y by del z, we will get, we have got e to the power minus z divided by 1 plus e to the power minus z whole square, right? Now we can further calculate it, right? We can, so we can write it like this: 1 plus e to the power minus z into e to the power minus z by 1 plus e to the power minus z. We can write it like this. We can just do this. We can whole square can we break it in this case in this form, and further we can also write it 1 plus e to the power minus z. We can write this 1 plus e to the power minus z minus 1 by 1 plus e to the power minus z. So if you just cancel out to plus minus, so again we will get the same equation, right? So now further if we solve it, so 1 plus e to the power minus z, so we can further just take it like this: 1 plus e to the power minus z by 1 plus e to the power minus z minus 1 by 1 plus e to the power minus z. We can write it like, again if we solve it, we will get this same equation, and after solving this we will get this equation. So if you see that here, this will be the cancelled out, right? So here what we will get: 1 by 1 minus e to the power minus z in bracket 1 minus 1 by 1 plus e to the power minus z, that we have got. And we know that 1 by 1 plus e to the power minus z is represented by y. So y into 1 minus y, right? So this is a whole representation of del y by del z. So this is a del y by del z. This is a whole solution for that one. Now we have calculated. Now we can put it here. So I'm just removing it from this to calculate it. So del by L by del y, that we have got here y minus t by y 1 minus t, and del y by del z that we have calculated, that is y into 1 minus y, right? This is a minus. If you see that this is a y, 1 minus, it is a y, not a t. Here, y into this is the whole equation. So that will be the cancelled out here. So what we are getting? Y minus t. So the value of del L by del Z is y minus t. So option B is the correct answer for this question. So is it fine to all of you? Or do you have any doubt? Just a minute. So any doubt or is it clear? Can we move to our next question? Okay, quickly moving to our next question. So yeah, our next question is an input of 128 into 128 cross 3 is passed through the bottleneck block, and these are the given for the each layer. So 1 cross 1 convolution layer, 64 filters in stride 1, and in the second layer 3 cross 3 convolution, 64 filters and stride 2 padding 1 is given, and in third is 1 cross 1 convolution layer, 256 filter is stride 1. So they are asking this, what is the final volume, final output volume? So anyone have any idea how we can solve this question? Sixty-four into 128. Okay. Okay, let's solve it quickly. So as we know that how we can calculate the output size. Yes, we need to apply the formula for the output size, that is I minus K plus 2P by S plus 1 for each layer. So first layer is 1 cross 1 convolution, 64 filters and a stride 1, right? So the input size is 128 into 128. So here we will take the input size 128 because the input, this one is the input size that is given, and stride the padding, there is no padding there. Kernel size is how much? Here 1 cross 1 convolution layer, so 1, and there is no padding is given, so 0, right? And stride is 1 for the first layer. So if you calculate it, here you will get 127. So 127 plus 1 is 128, right? Is for layer 1. So here the 64 filters, that is it is given, So that changes the depth, that is the depth of the filter. 64 changes the depth of the to 64. So the size for the output filter here 128 into 128 and 64 filters are there. So output for the one is 64. So 128 into 128 into 64 for the first layer. Now similarly we need to calculate for the second layer itself. So second is there 3 cross 3 convolution layer 64 filters. So again that will be the same. So here padding 1 is there, right? So 128 kernel size is here, it is given to 3 cross 3 convolution layer, it is given, right? So kernel size is, that means 3, padding is 1, so 2 into 1 plus stride is 2, it is given. So if you just calculate it, so here overall you will get 127 by 2. Now, so if you just divide it, you will get 63. So 63 plus that is a 1. So overall you will get 64, right? So the here the filter the maintains the depth, that is a 64 filters. So the size for the output 2 is here. So it is a 64, 64 and 64. Similarly, we need to calculate for the third layer. Yeah, 1 cross 1 it is given. So just we are removing it from here. So here if you just put all the values, so now the size for this one will be the 64, right? So here the special size for the third layer will be the, up to the first two layer the input size is 128, for the third one it would be the 64. So 64 minus k, that is a filter kernel minus 1 into padding is 0, stride is 1. So here if you calculate it 63, so here again plus 1, so here again you will get 64. So here 256 filters it is given here. So now depth will be the increases to 256. So the output size for the third layer 64 into 64 into 256. There 256 is the depth of the convolution, depth of the layer. Okay, so the final output for this volume is 64 into 64 by multiplied by 256. Okay, so option A is the correct answer for this question. Yeah, we need to apply the feature output features size formula. Is it fine to all of you? Okay, so if it's fine, so can we move to our next question? Now moving to our next question. So, okay. So our next question is in the XOR network, node R receives the input from an AND node and a NOR node. If the weights V8 is 2, V9 is 2, and bias is V7 is equal to -1, what is the output Y if both AND and NOR outputs are 0? Here AND and NOR outputs are 0. So what will be the output Y? So it in the question itself it specifies that and NOR outputs are 0 and assume the step function at 0 in that case. So now we need to calculate the linear combination for the output. Let's say Z. So let's say Z linear combination there. not working currently. So that is calculated by V8 into X AND gate plus V9 into X OR gate, sorry, NOR gate it is given plus V7, right? For any node, V7. For any node, as we know that it is a weight into biases, so we need to multiply like for any node. So if for any node it is given, then so it is a weight plus biases, right? Input into multiplied by this one and plus biases. So for one, we are calculating, right? So now in the problem, it is assumed that a step activation function for the activation, it is given a step activation function, right? That means if z is greater than equal to 0, then output will be 1. And if z is less than 0, then output will be 0, right? So here, if you calculate it, so V8, that is z is given as, so V8 is 2, and here both output and NOR is 0, so 0. Again here V9 is 2, again the output of the NOR gate will be 0, and V7 is minus 1. So Z is equal to minus 1 we are getting. So its Z is less than 0, so output will be the 0 in that case. Okay, so output will be the 0. So correct answer is B. Option B is the correct answer for this question. So just remember, for any node we are calculating input into weight, right, and plus biases. So that we have just put it there. So is it fine to all of you? Okay, I hope all of you have understand this question. Now quickly moving to our next question. So next question is, a feature map has a dimension 32 into 32 into 64. If each value is sorted as a 32-bit float, that is a 4 bytes, what is the total memory required for this map? So here the feature map is given, that is a 32 and 64. So the total data points will be the total data points is, if you calculate, so just calculate it 32 into 32 into 64, because they are asking for total memory, so we need to calculate. So if you multiply, so you will get 65, 3, 5 and 6. Okay, so in the each element data points occupies the 4 bytes, right? 32-bit and 4 bytes. So 1 8 bit is equal to 1 byte. So 4 bytes, right? So just multiply this each element 4 bytes. So total memory is equal to 65, 356 into 4. So if you multiply, you will get 262144 bytes. If you match this, you will get option B is the correct answer for this question. Yeah, that is correct. So now these are the questions that have been completed. So thank you everyone. Thank you for joining this session. Now questions have been completed. So if you have any doubt, you can ask. And also, this is our last class. So I hope all of you have gone through all the lectures and solved all the questions. So as a TA here, our work is to solve some problems that will be the similar to your assignment question. So that will be helpful to solve your questions. So that's why I have taken the questions only. So you have must you all of you have must have gone to the week video lectures. So content already you have. So I think I don't need to just go through that. So that's why I have solved the questions only. So if you have any doubt, now you can ask. Otherwise, we can close the session. And also, all the best to all of you for your exams. Yeah. So if you don't have any doubt, we can close the session. And all the best for your exam. So thank you everyone. Thank you for joining this session. I hope it would be fruitful to all of you. So anything you would like to ask or any doubt you wanted to ask? Anything? So if you don't have any doubt or you don't want to ask anything, then we can close the session now. Okay, if you don't have any doubt, so we are closing the session. Anything you wanted to ask? Yeah, Nina.
Ma'am, can you go to question 11 of week 12 again?
Okay. Yeah, this one.
Yeah, can you go to the next slide? I just wanted to confirm something.
Yeah. Yeah.
Okay, in the third step, we are basically looking at the neighbors, right? Like we have
Yeah,
already
yeah.
completed distance, we are looking at the neighbors.
Basically, these are the neighbors. So that is top, left, and diagonal elements only. The minimum
Okay,
of di minus 1, j, di, j minus 1, and di minus 1, dj minus 1.
okay, got it.
Yeah.
Okay,
So
thank
this
you.
is the formula.
Okay, thank you.
Yeah.
That'll be all from my end. Thank you, ma'am.
Okay, yeah. Thank you, everyone. Thank you for joining this session. Now, if you don't have any doubt, so we can close the session. If you don't have any doubt, so you can leave the session now. Or if you want to ask anything, you can ask. Okay, so thank you, everyone. Thank you for joining this session. Now I'm closing this session. And to all the best to all of you for your exams.